Good afternoon, ladies and gentlemen. This is still, review of days 1, 2, 3, okay, part B. So at this point, we've covered everything up to this guy right here, okay? So this video shouldn't be too lengthy. Hopefully, all of those sort of tied this concept or idea of trigonometry together, but basically, all the triangles from part A, right, are all proportional to each other. They're actually proportional to this guy right here, right? All of these triangles up above are just dilations, okay, of that same triangle, right? So here they're all multiplied by 2. Number 5, they were all kind of cut in half, right? And number 3, they're all multiplied by 3. And 4, I think they were multiplied by some sort of fraction, okay? But basically, these are all proportional to each other. All right, so anyway, so if you notice in a lot of those, right, we ended up getting the same sort of angles, 36.87, 53.13, and we also sort of got the same ratios, 0.8, 0.8, right, 0.8, 0.8. Okay, so hopefully that sort of ties all of these concepts in here, okay? And the reason why I did all those, right, because they're all similar triangles, and the whole purpose was to recognize that, like I said, that because they're similar, the ratios are the same, and therefore the angle measures that we ended up finding end up being the same as well, okay? So anyway, this one, right, it says given the right triangle in the diagram below, what is the value of x to the nearest foot, okay? So we're trying to find this guy right here, right? And so we're referencing this angle here. All right, and so this side over here is going to be the side that is opposite angle 40. This is always our hypotenuse, and this guy down below, 14 feet, or this side here, is the side adjacent to angle 40. Okay? So we have to think about, all right, which trig ratio involves our adjacent and our hypotenuse? That is cosine. Okay, so the cosine of 40 degrees is equal to, we'll just go 14, right, over x. What am I trying to find here again? Yes, very good. Okay, so in order to solve this, I'm going to multiply both sides by x. So I get x times the cosine of 40. So you go to 14, divide by the cosine of 40, divide by the cosine of 40. You get x is equal to, make sure your calculator is in degree mode. Whoops. Knocked over something. All right. Anyway, so 14 divided by the cosine 40. And so what is the value of x to the nearest foot? 18.27. Okay, let's go to the next one. Okay, and the next one, all right? We want to find x, and so this guy is our hypotenuse, and again, this guy is our adjacent side. Okay, so which one involves adjacent and hypotenuse? It's cosine. So I'm going to multiply both sides by 24. I get x is equal to the cosine of 30 times 24. And we get 20.78. Okay, and let's take a look at the last couple here. Okay, so we're going to use inverse trig here. All right, so what we're actually looking for is we're actually finding the angle measure based off of the ratio here. So AC, they're telling us AC is 29, and AB is 17. And we're looking for the measure of angle BAC, which is this guy up here. Okay, so this is our hypotenuse. This is our adjacent side. And so we're going to have to use the cosine of A is equal to 17 over 29. And so we actually get that ratio, 17 divided by 29 is 0.586. We'll go 2, 1. Okay? And then in order to find what the actual angle is, when you take the inverse of cosine, okay, what we're actually telling our calculator to do is, now those will cancel on the left. And we're asking our calculator, okay, what angle is associated with the ratio of 0.58621 for their cosine, right? So here's our triangle, right? And so if we're talking about this angle here, right, there's some triangle that has a ratio of 0.58621, okay, for this adjacent and hypotenuse side. And so we're telling our calculator, all right, here's our ratio, right, created by that side, those two sides. What angle measure is it? And so your calculator has all that information saved. So when you go inverse cosine, what you're telling your calculator to look for is what angle has a ratio for its opposite or its adjacent and hypotenuse leg of 0.58621. So you type that in your calculator, make sure it's in degree mode, and you should get this answer right here, 54.111. And we'll just round it up to the nearest degree. So 54 degrees. Okay? Excuse me. And then it says, find the length of BC. I'm just going to use exactly what we did before. All right, we're going to use our angle and one of these sides. So I'm going to have to use the opposite, right? So then I have to pick, okay, which trig ratio do I want to use, right? So I'm going to do something different. I'll do tan. Okay, so remember tan is equal to opposite over adjacent. Now we actually have an angle measure there, 54, and our opposite is x, and our adjacent is 17. Okay? And then we just multiply both sides by 17. Tan of 54 times 17. X is equal to 23 point. We'll round it to the nearest inch, it says. Okay, so 23 is going to be 23.4. So x is equal to 23 inches. And our last problem here. All right, so in the right triangle ABC shown below, there's our two side lengths. What is the measure of angle A? Okay, so this is our opposite. This is our adjacent side. Again, we're going to have to use tan. So tan of A is equal to 11.2 over 18.3. And so what we're going to tell our calculator to do is when we take the inverse tan of both sides, okay, the tans on the left go away, then we're left with A is equal to the tan -1 of this ratio here. Okay? Now, that's an actual number there, right? 11.2 divided by 18.3. Okay? We get this nasty number of 0.61202.18579. Okay? And so what we're asking our calculator to do is we're saying that there's an angle associated with that ratio between its opposite and adjacent sides. So the calculator has all that information saved. So we're telling our calculator, okay, this is the ratio we're getting for tan, for the tangent, right? Our opposite over adjacent, we're getting this 0.61202.18579. And so we're telling our calculator, okay, what angle measure is associated with that answer? And we end up getting A is equal to 31.5, the nearest tenth of degree, so I'm happy with it, 31.5 0.5. Okay, so what it's saying is that the ratio created when you have a 31.5 degree angle with its opposite and adjacent side, okay, the ratio created by that triangle, no matter what the size is, as long as you have that piece and that piece there, the ratio for that opposite over adjacent side is always going to be that 0.6120218,579. Okay? And so that is what we're up against. All right? So hopefully this I think that's all of them. So the rest is for homework. Okay, 1, 2, 3, 4, 5 homework problems. Okay? And so if you have any questions on any of this stuff, please don't be afraid to ask. Otherwise, hopefully this video you found useful. And hopefully at this point you guys are sort of getting that stuff. Sorry I keep moving that around, I'm just fidgeting. But anyway, all right, so that was 3 and 4. And then the rest is homework here for you guys. Okay, so any questions on that stuff, please feel free to ask. All right, other than that, good luck, you guys.